So I hope that made sense now, and we'll have a lot more of these problems. I kept it pretty short just so that you weren't both having to learn this new tool for working through your homework and a huge problem set at the same time. But I did see a lot of you get in there, not quite everyone, so I encourage the few of you who haven't hopped on to the REPL or whatever, taken that link and created an account and stuff to go do that so that we can see the progress. It's by far the easiest way for me to get a feel for where you're at on any of the work that we've been doing. But what we're going to do now is continue to work through some more array examples just to help reinforce this a little bit. And then if we have some time before noon, we might start getting into the idea of functions, but I don't know how much time we're going to have. So let's go ahead and do some reviews with arrays again. Here I've got some, feel sorry for whoever is going to be listening to this, because I'm probably going to be over at the screen more than anything else, but we've got some arrays that we've created. Can everyone read these arrays just fine? Yeah? So let's just sort of go around and have people give us the answer as to what each one of these expressions will do. So let's start with evens 2. Give us what the result of evaluating evens at index 2 would be. All right, perfect. What about odds at index 10? Defined, yep, because we only go up to index 2. Now one that's a little more complicated. Foods at index 2 plus, oh, I missed a plus here. I need to add that in. Let's assume there's a plus here and I didn't mess that up. Foods at index 2 plus space plus foods at index 0. Yeah, other way around. Because we got index 2 and then index 0. We got that right. Right? Another that is good. All right. Now let's go with what about foods 0 less than foods at 1. It's a tricky one. I don't know what the answer is. We'll go ahead and evaluate it to see. False. All right, let's find out here. It is true. Yeah, this is tricky, but anyone want to take? Let's have some guesses as to why. Did it do the length of the string? That's a good question. Let's see if we can test that. Let me get a. Let's try.
So we do foods 0 greater than foods 1.
But the order of these is not going to be the best. So let's try on sodas and let's see if our assumption is correct. So I think we've got a good one here that we can probably use, where Pepsi is definitely shorter than Mountain Dew, right? So if I were to do this comparison with those two, what would that be? It would be sodas 2, and we think it should be less than sodas at 4, if we think it's length. So we're sort of testing a theory here, right? All right, that says that's false. Any other guesses as to what it's doing? You think it's the index location? All right, well, let's see. Let's see if we can test that. Let's see if, let's do sodas 0 is less than sodas 1. That's false. And it's not the index location, and that's one that if we think about it, we can break down and say it's probably not true because it evaluates the whole expression. So when it's actually doing this comparison, it's not comparing an index, it's comparing sprites to code. Any other guesses? This is a challenging one, but it's good to think about, like, I don't quite understand why this code is doing this. Can I try and figure out why? I'll give you a hint.
Alphabetical order.
It's alphabetical order. It's using the first letter in alphabetical order. So if we get rid of the array and instead we try and do like B is less than A, of course I did my quotes wrong. That's false, but A is less than B is true. So when you're comparing strings, you're comparing them off of alphabetical order, or close to it. Not quite, but close to. Because, let me try B is less than A. Oh, maybe it is completely alphabetical in JavaScript. It might actually be doing a lowercase conversion, I'm not sure. Or let me try it the other way here. Would it be B is less than A? Well, that should be false. All right, so that one doesn't make sense, right? Because B is less than A. It's because it's not quite alphabetical order. We'll go into it, but it's good sometimes when you run into code, you don't quite understand how it works. Just throw some assumptions at it, try some things out, and see if you can figure out how it works. Because that'll happen to you all the time. It's almost like the scientific process. All right, I'm assuming that it's this. Let me throw some tests at it to see if that's how it's actually working. In this case, the reason why this one's separate, works a little different, is because it's alphabetical for lowercase and then uppercase, or uppercase and then lowercase, I guess, is the way they're actually stored. So an uppercase letter, I think any uppercase letter will be less than any lowercase letter. So Z uppercase will be less than A because all the uppercase letters come before the lowercase letters is how it works. And that's actually just, so it's not exactly alphabetical, it's how letters are encoded in a computer, the way that it's encoded, but that's sort of how it works. All right, so let's move on. What about evens dot length plus foods dot length? What do you think the result of that is? 5. So what's the length of evens? It's the tricky one. Yeah, it's the off by 1 stuff. Length is the actual length. Could be 7. Yeah, because length is the actual length. It's not giving you the last index, right? And then one last one. So does it -2? What? Undefined. Yeah. All right. So just some basic practice of some arrays right there. And then we also have, let me see how much time we have. We got about 20 minutes. I don't think we'll go into some of this manipulating arrays. I might just make some of these homework to do some more work with arrays here. But let's go ahead and build this bit of code together. So let's find the average of all the numbers in an array. So if these are the numbers in our array, or if this is our array, and I've given you a lot of the template code around it, we just have a couple places to fill in for logic. So let's go to this first piece, inside of our while loop. What are we missing in our while loop to try and work towards being the average of all the numbers in an array? What? What was it? This program is trying to give us the average of all the numbers in an array. So we've got an array, and we have a variable to hold our total. Well, maybe I can rename it sum. And then we have an index for our while loop that we've been using, right? So we've got two pieces of code that are missing for this right now. We have what we're going to do inside of our while loop for each step, and then how we're going to compute the average. So maybe we should do the average portion first, because it might make the while loop portion easier. How do you compute the average of a group of numbers? What? Okay. Then divided by the number of items, right, that you're averaging? Okay, so if we were to write that here, what would that look like sort of here? Let's rename this to sum, because you said sum, I think that seemed clear. So if we want average to be our average, what would we put here to sort of do that? So let's assume that the loop has done something to correctly give us what this sum value is.
First of all, I would say if it is a function, can give us the.
We haven't introduced functions for everyone else yet.
Okay, so in this case, what I would do is
But
assign the index. I mean the number, but array the index of. That way, the whole variable, the whole array is
So you're saying in this while loop we want to take a certain step for each step in the while loop, right?
Yeah, I was talking about the variable array.
Okay. Yeah, let's assume right now. Let's assume that let's just assume that the sum variable by the time we're here has the sum of all the numbers in the array. Sum divided by numbers.length. All right? And this is a really good way to code too. You notice what I did is I stepped over. I said, let's assume that by this point in time, sum has what we expect it to have. I'm not telling you how it got there. We're just going to assume that that is a true statement at this point in time. And something magical will solve that for us before we get there, right? This is actually a really, really powerful concept to get when you're learning how to program. And that's the idea of, okay, I don't know exactly how to solve this sub portion of my problem yet, but I know this later portion, or I know this bit. I know what I need out and how to work with that, which is what we're doing right here, right? So let's assume that that's correct. Let's make it, write it out as we would expect, and now let's go back and solve this other bit of the code so that we can get that sub portion of our code working, right? That way we don't have to try and think about it linearly, and we might get stuck on the hardest part of the problem at first when there's all these easier pieces. And once you put those easier ones in place, the hard part may be simple to figure out. Okay, so now our job is to make sum actually equal to the sum of the items in the array. So we need to do something inside of our while loop to accomplish that. Our sum. So what do we think we should do here? So what?
Assign the index of the array.
So numbers index to the sum. All right, let's test that real fast. So it tells us the average is 4.6 right now. That's not right. There's no way the average of these 5 numbers is 4.6. So we're missing something.
What number is number?
What? What numbers is numbers index? Okay, well let's do this. Let's log it so that we can add some sort of debugging here, right? Let's log this, and then let's log the sum too, after we set it each time through the loop. And let's see what we have. All right. So now if we run through our code, we see that the numbers index the first time through is 60 and our sum is 60. And the next time we go through our loop, we back up here. Numbers index is 78 and our sum is 78. And 97, 82, 23.
So it's not adding together, it's just going through, telling you the sum is each.
It's just reassigning it, right? Because all we're doing here is assigning the current. We have to add them. So
the numbers index plus numbers index.
well, that'll put twice that numbers index into the sum. But let's say, I mean, this is a sum, it's a running total. Yeah?
You create a variable that takes the value of each number to a while loop and then adds it to the sum.
We can do that, but you can also use the sum variable for that. Because the sum variable, if we look at our run through here, right? After this first time we ran it through, sum has 60, right? And that's because we just assigned numbers index to it. And sum already has 0. So what if we just add to our sum every time? So our sum will start at 0, and then the first time we run, it adds 60 to 0, and then adds 78, and then adds 97 to that. So if we run that code, now we get something that looks a little more appropriate, right? Like our sum is 138, 235, 317, 340. And so it went ahead and increased our sum every time, and then we got the division we were expecting. What? Are you messing with me? Does that make sense? How you can sort of build something up that way over time? We'll definitely have some more homework assignments that fall into that vein, working with arrays like that, but and loops in that same sort of approach. So let's do another one more collectively, and then I will just start introducing the concept of functions. It's going to be a little bit of a whirlwind introduction to functions, so not nice and in-depth, but we've got another problem to solve. This one's sort of in the same vein, but works a little bit differently. Let's find the longest word in this array. All right, so I've given you some template code here to start off with. I'll add a console log at the end so that we can have that, but we've got a list, an array of words, and we've got this variable that we want to put the longest word in, right? And then our index and our loop and stuff. All right, so let's assume, again, let's make the assumption that once we're out of this loop, longest has the longest word in the array. So the way that we would show that would just be longest, right? We're making the assumption that whatever this loop is doing is correct, and somehow it's getting us the longest word. Now our job is to write the more complex code inside of this loop to try and find the longest word in the array. You don't want to take a stab at how we can start this? What? All right. Yeah, you already jumped to what you need, right? You need some sort of conditional in here to find out if the word that you're working with is the longest one that you've encountered somehow, right? So we need some sort of if statement. All right. Now, what do we want to do inside of this if statement? So we need to compare something to, get a Boolean result. Yeah.
If this is greater than the index.
Well, how do we get the current word? List index, okay. So that'll give us whatever word we're on this time through the loop. And what do we want to maybe compare that against to see if it's the longest word? Well, what? With every other word? Let me give you a little trick here that might help out. If I have I don't know, a bunch of words, and they start, you know, with like, they have either like 3, 4, 5, 6, 7 letters or whatever. Once I've realized that I'm looking for the longest one, and I have a word of 4 letters, do I care if I see a word of like 3 letters anymore? No, because it's not going to be the longest, right? It never will be. So in other words, once you've gotten a word of a certain length, you just need to sort of compare and see, hey, is anything else, is this next thing I encounter, in a sense, is it longer or not? If it's longer, then let's just assume that it's the word I want. And if it's not longer, then I'm good. I already have the longest, right? So we already have a string here, an empty string with nothing in it. So let's step through this loop for the very first time. Let's think about the loop step by step. First time we go through it, index is 0, longest is an empty string. And so if we want to, so if we look at the lists at index, that gives us bananas, right? All right, now let's just assume that this is, let's make it even simpler here for a moment. Let's say that is our list right now. All right, the list is just bananas. Now, what could we do inside of here? Maybe it's even super simple to get the longest word out of put the longest word in that array into longest. Dot length, that'll give us the length of the array, not the actual word. Oh, I get what you're saying. No, you're right. My bad. So hold on. Now in this case though, remember, we've made this list very, very simple. So we don't even have to have complex logic because we can solve this with the first pass just by doing something like longest equals list at index, right? And then, of course, I have some code wrong here. It's because I called it list, not plural. All right, so it works, but it works because it's trivial, because we could have just gotten lists at 0 and been fine, right? But now let's go back, let's add make this a little more complex, add our earlier array back in, get rid of this one. And now let's say on our first pass through, let's assume that this first word, our first pass through, we definitely want to put that in, right? So if we have this if block here, what sort of comparison can we make that will put that word into it no matter what right now? We could compare the length of the longest string, because you do have length on strings. So if longest.length is less than, this is getting back to exactly what you were saying, Casey, listindex.length. Well, we could do, let's make it even more basic. Let's go back to what we just had so that we can bring this back in. Let's just say longest equals list index, right? All right, now what happens here? It spits out kiwi, and that should be no surprise because that's the same thing that we were doing with our sum before, right? We're just assigning each time we come through, so it ends up with the last value in the array when we're done. But that's not quite what we want to do. We only want to assign it to a value if whatever that value is longer than our current longest word. Right? So that's where you say, a moment. That's where you say, like, okay, this is conditional logic. I want to put this inside of this if block so that I'm only doing this assignment when it's longer than our existing one. And the comparison you can make is, oh, if this word is longer than the current longest word, then reassign longest to it. Otherwise, it's going to keep the value that it currently has. I don't know what I did there. Let's see here. If we run that, does that make sense? Why that's working that way? We can step through it pass by pass, right? So let's go through again on the first pass. All right. So longest dot length in the first pass is what? 0, because we have an empty string. But list of 0 dot length is 7. Is that right? If I can count. That's how long that string is. How many characters are in it? So it's going to be longer than 0. So longest becomes bananas, right? This first pass through. In fact, we can even watch this. Let's go ahead and add our log in here like we've done other times. See what happens as we run through this code, loop by loop. So what's going on? We have bananas, all right. So now we come back in, and now index is 1. So we look at potatoes, and now we're going to say if bananas.length, which is 7, is less than potatoes.length, 1, 2, 3, 4, 5, 6, 7. Yeah, there we go. So, okay, it's longer. So we assign that into longest, and we have potatoes now. Come back through the loop. We look at mangoes. Well, mangoes is just 6. So that's shorter than 8. So we're not going to reassign it. So you can see that bananas, potatoes. Now we get to raspberry, which is 9. 9 is longer than 8. So now longest will have raspberry. And then we run through 2 more times for 7, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there may be an interesting question there, right? Wait, for 7 that's 9 too. Why are we holding on to raspberry and not for 7? I don't know. Might make it a homework assignment. So we don't change our value because it's not longer than our current value, or it's not less than or equal. So it's still raspberry, and then kiwi is just 4. Still less than, so we spit out raspberry. Does that make sense how we put together these pieces, the while loop, the if block, conditionally assigning a value or reassigning a value so that it only changed in certain cases? Any questions? This is, I think this is sort of one of my favorite starting examples of composing bits of code. Learning how to use these different pieces, if, loops, assigning values, comparisons, to build something a little more complex. Because it's pretty small, pretty simple to understand, and yet a great example of that sort of composition of concepts. And it's already noon, so we probably won't get into any of our talking about functions. We'll just start diving into functions in the next class then. But functions are really a fundamental. I guess I'll just introduce the concept, and then we won't look at how to actually write them. That way, it'll get in your mind, and we'll review more next time. A function is just a group of statements that perform a task. So a statement is any one line of code. It's index plus plus. That's a statement. In JavaScript, you end a statement with a semicolon. And a function is a group of statements that perform a task of some kind. And the reason that functions exist in code, the reason we use functions, is because it allows us to write code once and use it multiple times, which is huge. It allows using the same logic with different values. So you don't have to always have some hard-coded values that you sort of pass in. We've been doing that a little bit with arrays here and while loops. We're sort of reusing some of the same logic with different values inside this while loop. Functions do that. It also allows you to break code up into smaller pieces. I was just talking before about, think about, oh, let's just assume I got this value correct. I don't care how it gets computed, and I'll work with it. And then I can go back and solve the problem of how do I compute that value correctly later. That's functional-based thinking. You break it down into these small pieces that you solve and build something up larger out of that, instead of having to try and think of the whole program at once, which you're not going to be able to solve. They also allow you to isolate variables and logic so that you don't have that sort of scattered everywhere. And people remember when we talked about machine code versus assembly code versus higher level languages? Functions are another thing in this same chain. And the general concept that all of these fall on is what's known as abstraction. Abstraction just allows you to think at a different level. Think at a higher level and not worry about the details at that lower level. So when you abstract something away, you can say, I don't need to right now think about all those details of how this lower level thing works. I just need to think about this higher level and how to put stuff together. And then I can go solve that lower level item later. And reuse that lower level logic in a lot of different places, not just one place. So that's really a lot of the benefits of functions. And then next class, we'll get into starting to write functions and really building much more complex applications by composing our stuff of different functions.